Welcome back, everybody, to another episode of Energy Bites. Rad Dad is here today. We had Fuse earlier this week, so thanks everybody that came out. I'm actually repping a honeycomb shirt. Thanks, Oleg. Shout out to Oleg for giving us some stuff. I've actually decked out my my cup as well with a bunch of new honeycomb stickers. They're pretty good. Oleg, I know you were behind those, so keep doing them. They're legit. Here with Bobby today. How you doing, buddy? I've got one for you. It's in the truck.
Sweet.
I just forgot to bring it inside. And today we've got the founder of Kelvin, Peter Harding.
Hey, nice to meet you guys.
Thanks
welcome.
Thanks for coming on, man.
Absolutely. Happy to be here.
Yeah, I'm glad we could catch you while you were in town.
Indeed.
That works out well. Well, let's jump into it. So, you're the founder CEO of Kelvin currently. Kind of walk us through, where you from, where you grew up, how you got kind of into energy, and then to a founder of a energy tech startup.
Totally. Yeah. So again, thanks for the time today. So born and raised in the Bay Area in California, and was really active sort of as a kid in a lot of kind of different engineering endeavors, and got excited about building stuff. Fast forward, I was thinking about one of the big catalyst events for me was actually the Persian Gulf War, around an awareness around energy.
Sure.
and a recognition that I didn't really understand why we had a whole bunch of our troops over there, and was trying to sort of rationalize that as a kid. And that was interesting in the sense also because my dad's a two-time Vietnam vet, had a couple tours and had really gone out and made that sacrifice. And I was trying to understand sort of his effort and commitment versus why we were out there sort of in the Gulf War. And that sort of energy dependence as a kid really resonated with me. And so I started to think about what types of technologies, other things in the future are going to change that. So fast forward, I became aware of a lot of the kind of interesting work that was starting to happen around directional drilling and fracking, kind of going back, this is, pushing 20 plus years ago. And as a kid from California, that's not necessarily top of mind. But for me, it was one of these, both of those technologies were so transformative that, but not necessarily appreciated in parts of the Silicon Valley.
Still aren't,
right? And I say that with, I have the same sort of appreciation that I think many folks in Texas do for, frankly, how hard it is to do that and to make those systems.
It's really mind blowing when you think about what
totally
miles underneath, miles out.
Exactly, 14,000 foot lateral.
Nobody talks about it.
No, and so when I started to think about it, I'm like, wow, that's really interesting. What types of things can I bring to potentially be a sort of as an entrepreneur and a person who's interested in building things, what types of technology can I bring to bear to potentially aid and support some of these things? Because I do believe that where we are today at 13 million barrels per day as of, I think that I saw that statistic, right? Which is sort of that was pre-pandemic levels. We're back to that. That's a function of what we've done on sort of the work in the US, right?
Yeah.
And that's amazing.
Yeah, it's funny when you think about that and you look at the peak oil decline curves and stuff, and you're like, it goes like this, and then the shale boom kicks off and it just comes right back up. And I think that's a just sidebar, but I think that's the thing that somebody mentioned this actually at Fuse. When people account for technology and they forecast stuff, they don't forecast that, and you can't, right? You can't forecast new things that haven't been invented yet or that haven't been proven yet, or things like that. But the weird thing about commodities is the higher the commodities price, the more potential there
find
is.
a way.
Right.
$14 an MCF gas, and all of a sudden, hey, we can crack.
Exactly.
Yeah.
Well, I was with, sort of fast forward till we can talk about it, but just along those lines, a couple of weeks ago, I was back at the Climate Impact Conference. One of our investors is OGCI, or now Climate Impact.
Okay.
And Vicky Holub was talking about some of the work that Oxy's doing. Right? And, today they expect, traditional expectations are we get about 10%, out of
the recovery factor,
what our recovery factor is. And you look at some of the potential in terms of, new ELR techniques. And we're talking about like 19%.
That's it's insane. I mean,
right?
Even like I think that was something that like almost an arbitrage that they're thinking with Exxon, because Exxon's over here pumping that they're going to 2x their recovery factor. Well, if you just 2x your Permian footprint and you can 2x that, now you got 4x potential.
Right,
So
So I get excited about step function changes that technology can bring, and I have for a long time. I think that's one of the beautiful things about growing up in the Bay Area is like you see how technology has such massive impact, right? And then you think about, okay, well, what are the sectors where that actually can have far-reaching, sort of longer-term impact? And energy is one of those, right?
Sure.
So back in really in 2015 is when I started to spend some more time specifically working kind of in the oil and gas space. And this was a function of I got introduced by a very good friend from business school and now an investor and board member to a small oil and gas operator that was based in Ponca City, Oklahoma, that was trying to figure out how they could optimize production. And I had worked in technology before. I'd been on the investing side previously. I'd kind of gone through during business school. I was always trying to figure out new businesses to start.
Sure.
And I started to see where there were opportunities to use more of these kind of advanced like hardware solutions that were coming out that were most notably kind of in phones, right? So you had different types of, you had magnometers, you had different accelerometers, you had all sorts of stuff that's now sitting, it's like supercomputer effectively in your hand. Can you start to use some of that technology plus advances in data science, plus the reductions in costs in compute power and storage? What could you do with that? And through this introduction, we ended up realizing that we had a technology that was able to understand movement in a very precise manner. And what we did was we took Android devices, we put them in basically plastic boxes, and we zip tied them to pump jacks out near Ponca City.
Yeah.
And we started to find interesting movement patterns in that. And what we realized was if you could correlate the different movement pattern to different downhole conditions, you were sort of starting to be able to do what some of those, old school operators do when they walk out there and they put their hands on the pump and they listen and they understand like there's a whole bunch of signal that comes through that.
Yeah.
We're like, cool, can we capture some of those details? And we started to, we built from that point.
Yeah.
And fast forward, what we realized was that was helpful. Like the hardware stuff was interesting, but as I like to say, they don't call it easyware. Right?
No, yeah.
So there's a piece of this, which is, can we do more and more of this originally pattern matching into, so some sort of pattern leads to some sort of an insight. And then from that insight, do you take an action?
Sure.
Right. And Kelvin today is really all about taking insights to actions. And we focus on this concept of we want to be able, our mission is to deliver autonomous operations.
Yeah.
Okay. To do that, you have to start with applications optimizing assets. And so that's, what is an application doing? It's taking a series of inputs from what could be the data streams that are coming off of a particular well, and using that to find the patterns which inform some sort of an action, a speed change or otherwise.
Yeah.
And what we've realized is that you don't need to, that concept of I have inputs, I have logic, and I have outputs, like that becomes something that's extensible across a whole bunch of different parts of an operation. And in many ways, it's kind of what the engineers do on a day-to-day basis, right? So we look at it and we say, what does your best engineer do on their best day? Right.
Yeah.
And typically what they're doing is like they're synthesizing some information, right? They're deriving an insight, right? They're taking an action and they're measuring that impact.
Yeah.
Okay. That's a day-to-day engineering workflow. Can you do more and more of that actually in software, right? And can you make that, what they're doing as kind of a series of manual processes, can you turn that into something that runs consistently and more automatically?
Yeah.
And that's what Kelvin has really evolved into. So we started with pattern matching, interesting sort of signals coming out of those pumps, to today looking for those signals, but turning those into insights and then taking actions. And through that process, we are delivering on this concept of moving towards autonomous operations, right? And as you know, it's kind of from a data science background, the more that you're capturing those work streams, the more that you're able to measure those impact, the better you're able to then predict what's next.
Yeah.
And you can start to learn and you can start to connect more of these things together, not just as individual assets, but as part of a broader system.
Sure. So like, can you kind of bring that in then, how that improvement then helps with buy-in? Because I mean, like, again, or we can just talk about buy-in with AI, ML, just in general.
Totally.
And because
that's a good topic.
You talk about you're working
unpack.
with field guys that think you're going to replace them.
Yeah.
So, I mean.
So if you go back into our history, sort of 2015, 2016, a lot of our initial approach was, hey, we have an algorithm, right? We have an approach that we think is going to be able to optimize this particular asset type. And we're very good in terms of getting buy-in from senior level folks.
Sure.
And then we sit down with folks who are like, wait a second, this does what I do. This is a threat. And in that situation, you get a very natural reaction where folks are going to try to sabotage what you do, right? Makes sense. What we realized, though, is that rather than coming up with an alternative, and hey, here's a better model, can we instead look to figure out who on your team is doing it the best?
Yeah.
Because if we can capture and codify what your best engineer is doing on their best day, that all of a sudden changes the dynamic.
Yeah.
Because now they're like, oh, wait a second. I personally get leverage because I'm the best at this and I don't like to do all these manual tasks. So if I can describe it, turn it into an application, it frees me up. So I get some benefit. But the next piece then becomes maybe the other guy who's pretty good thinks he's better.
Yeah.
Right? So James thinks he's better than John. And James is like, well, I can build a better algorithm. I can build a better application. Let me show you. And you get this interesting dynamic where versus us coming in and saying, hey, we can do it better.
Yeah.
We're like, no, you can do it really well. In fact, the constraint is oftentimes the fact that the best engineers don't have enough time. Right?
Yeah. It's 24 hours in a day.
They have 24 hours in a day. So, so the common refrain that we have is, you look at all the objectives from the CEO. So I'd listen to a lot of earnings reports and I've been doing, talk about using Gen AI. I use Gen AI to go through and like synthesize earnings releases.
Yeah.
What are the CEOs talking about? And there's sort of 4 things that we hear about on a pretty consistent basis. You need to increase production. You need to reduce cost. I need to achieve my ESG objectives, right? And I need to maintain safety. Well, that's a lot for one. Those are conflicting objectives if you think in certain cases.
Yeah, they can be.
Absolutely. And how do you balance, right? How do you think about that? And that's where we started to realize that if you can put those types of objectives into an application, you then freed that person up to be able to work on higher order problems. So you're getting a lot more leverage and you become a force multiplier
100%,
for the engineering team. And that's really where we have come at this now. So originally it was a much more adversarial sort of first sale. And now we're like, guys, we know you're buried.
Yeah.
Right? Like you don't have enough time to get your stuff done. What can we do to help you? And because it's now so easy to build an application, and that sounds like a big word, but really it's if this then that in certain cases to start.
I mean, that's AI in general, right?
Well, there's
nested if statements.
That's right. So in terms of sort of demystifying some of the AI piece, we talk about this a lot with customers. AI is not evil, right? Yeah. Nor is AI omniscient, right? AI is going to be a tool, right, for you. And the thing to do is to understand how to use it appropriately, okay? And if we can help your existing engineering team get leverage out of the fact that AI is now a useful tool, it's not going to take away their job. No. It's going to free them up to be able to do more and to again focus on higher order problems.
Yeah. I mean, I think there's a couple things I want to hit on there. I mean, definitely a force multiplier. I mean, talk about Gen AI, say I've got GitHub Copilot running in my IDE. Now I can write a script in 5 or 10 minutes that would maybe take me an hour just to hack together,
right?
Before. So again, frees up more time. So I mean, y'all are trying to play that role, it sounds like, in the engineering space, essentially.
Yeah, and our typical users are two of those categories. So we think about production engineers who are the ones who are utilizing the applications that are been created, and we have software engineers who are oftentimes building applications. Yeah. Now, that person could be a data scientist or otherwise, but typically they have some understanding of how to develop in Python or at least a basic, sense for sort of how to set up a model. And then what we try to do is create a really easy way to take that model, and we talk about like every model really wants to be an actor, right?
Yeah.
There's a lot more money in it. Okay.
Fair enough. Yeah.
So how do you make that conversion?
Sure.
And when you do, then it becomes interesting because we know that there's a ton of unutilized models, right?
Sure.
There's a lot of stuff that's sitting on the shelf. So can you unlock those? Can you empower them? Can you put them into real operating environment in a safe, secure, and scalable way?
Yeah.
Right.
And I think another thing I want to get on there too, because it seemed like you're talking, you take, say, your best engineer or best couple engineers. And so then you're able to institutionalize that knowledge, which is I think a big thing for me too. We're always trying to recycle. All right, you've got that in a Power BI or a Spotfire project. I want to pull that logic back into our data warehouse where it's source controlled.
Totally.
And then again, it's the proverbial Johnny gets hit by a bus thing.
Yep.
But I think another thing too is if it's wrong in the same direction.
Mm-hmm.
I think that's understated. Like, like a really bad golfer slices and hooks.
Yep.
And you have no idea how to fix it. But if I only hook, I can know what the fix for the hook is and I can straighten it out.
Yeah.
But like if I'm all over the place, right, left, you're screwed.
Totally.
Like, so I mean, like at least with this, like there's some directionality. Like if the models are veering off, they're going to veer off together.
Yep.
In the same direction. In theory, in most cases.
I think that's oftentimes the case.
Yeah.
Right. But I think this is where, again, getting into the buy-in, right?
Yeah.
If you've got folks who are on the production side who are saying, "Hey, I'm crunched. I don't have enough time."
Yeah.
And I could see how these tools are valuable.
Yeah.
That's great. Like let's try it, and let's also do it in such a way that it's not cost prohibitive and it doesn't take 9 months of meetings to kind of get something up and running. I think one of the other pieces around your buy-in question is it's just a lot easier today to get this stuff implemented.
Yeah.
And that's a huge shift. Both, I think psychologically, I think folks are more open to different types of technologies being useful. And two, the technology itself is just way, way more powerful and easier to implement. And you're using your GitHub Copilot to build stuff. There are already, and we've done some of this work already, to be able to say, like, we can build similar tools to help that production engineer.
Yeah.
Like, I got to go synthesize, I got all these documents I got to get through.
Yeah.
Like, and I can do 3 well reviews with my geologist and with my reservoir engineer in a day.
Yeah.
Like, can I up that to 10?
No, yeah.
Like, those types of things are where we're starting to see, again, very targeted applications of different types of AI. And AI, again, it's this catch-all, right? And I like to be a lot more precise about what we're talking about. So as it relates to Gen AI, I think there are some really interesting tools around document synthesis.
Yeah.
But it's great. It's great for batch data. Can't use streaming data
right
through those systems right now. But can I go through and have it look, be able to understand, okay, analyze these different documents, give me some signal from that saves me time. Great.
Yeah. Pump cards and
I think the pump card stuff is going to be interesting. I'm even seeing, I just look at go through the existing documents and tell me about, am I in compliance across all of these different wells? Like, do I have anything that I need, I need to increase my pumping at this particular well? Like those types of things are even simpler examples to start. And then what we'll find are more and more opportunities to use these tools. The truth, though, the biggest challenge that we've seen is many of the legal departments are still unsure as to how these AI tools are going to get used. And so we've seen in certain cases, folks just shut stuff down.
Mm-hmm.
And that may hold. I think we're, as folks are more skeptical around how this works, there may not be rapid adoption, but the major cloud players are all pushing to get better access.
Well, and at least with some of that too, I mean, I know obviously Microsoft is investing hugely in OpenAI, but I mean, they've already got stuff where you can create your own vector database within the Azure platform and it's governed and secure.
Totally.
I mean, Databricks, I mean, you name it. I mean, they're all at least saying they are anyways too.
Yeah.
But I think it's also some of that whole crossing the chasm thing, right? I mean, some people are just going to wait and see, and they're going to wait until other people have proven it out, and other people will reap the benefits earlier, or maybe fall on the sword. Who knows?
Fast followers.
I mean,
what most of my edge stint at HiveCell made me truly realize that oil and gas is not the only industry that is a fast follower. It's pretty much every major industry has that's Crossing the Chasm is such a good book because of that, because it
Absolutely.
doesn't matter what industry it is. Technology adoption is the same.
Yep.
Everyone doesn't want to, for the most part, put their necks out and be the first one to risk it and then fail and fall on their face and then all that stuff. But once someone has something and you can come to a customer and say, we're working for so-and-so, it's amazing how much quicker those next meetings come.
Totally.
Just because you're now working for whoever.
Yeah.
And it's a weird dichotomy. I also think a lot of the initial, 5-10 years ago, even, a lot of the tech companies that were coming into the energy space were coming at it from a purely technology side.
Yes.
And whether they knew it or not, they weren't, like, to your point, just how you framed the conversation with the clients completely changes how they approach you and,
absolutely,
and their reception of it and their perception of it. And so being able to, engineers like to think they're the smartest people in the room in most cases.
Because they are. All of them.
And so instead of coming with them with, hey, we've got this custom model that, I can't explain to you how it works and you'll never understand how it works, but I promise you it'll work, to you guys have the models, or you guys can build the models, or you guys can guide us on the models, and we'll help you implement, scale, train, deploy, manage. Makes a complete difference, right? Like, because anytime there's involvement from the end user, the buy-in is so much easier. Like,
totally.
I learned that in industrial engineering, but it's working on the factory floor. It's like, hey, we're trying to make improvements to shave a minute off of the production time of this thing.
Yeah.
Well, guess what? The first people you should go talk to are the people that are doing the production of that thing. Because I guarantee you, if they've probably tried a bunch of things that you're going to come up with out of the gate. Right?
That's
like
right.
It's
I think there's been historically like a lot of hubris as folks have come into this market with the, hey, we know better. And listen, I guarantee you there were people in this market who would accuse us of that, historically. Sure. And I think what we've really tried to do is switch our perspective and the way that we approach with a lot more empathy, right?
Yeah.
Which is what you have real issues that you're trying to solve.
Yeah.
Can we understand those?
Yeah.
Right. And once we understand them, maybe our technology is a useful tool. Maybe it's not, but at least you can articulate what those issues are to us. And if we're not the right, if we're not the right partner for you, we can probably direct you to somebody who's a better fit.
Sure.
That's a different way of approaching this market than I think certainly a lot. I mean, there's a lot of folks who have tried to bring advanced software, AI,
of course,
fill in the blank into the space and have just failed miserably.
Well, and then you get the push from investors and stuff, right? And they see the giant market cap for energy and they're like, oh yeah, that we want to be in that space, until they get in that space and they realize that, it's going to be 2 to 3 years before you do any work for a super major, just because that's how they work.
If you can find the right person.
Right. Well, and that's the thing.
It's a year and a half to find the right person.
Like, oh, well, if we can just land Shell or Chevron or one of these giant companies, it's like, you're going to spend 3 years doing it. And that's just the life cycle it takes, instead of going and targeting some of the smaller independents or the smaller PE-backed companies who their objective is to reduce cost. Like, they are much more incentivized directly to implement things that are going to drop costs, improve production, improve efficiency, because their whole plan is an exit, right?
It is the bottom line,
the bottom line is what's so much more important, because everyone wins on that.
But what's interesting? That's even evolved in the last few years, right? Because when I first started, lots of PE conversations, and folks are like, well, all we're going to do is punch a few holes in the ground and flip it to the next.
Yeah, there's that too.
Right.
That's changed a lot.
Yeah, and so that, I think what we're
also they're not even going to waste time and effort implementing this new technology, because we might not be here in 6 months anyways.
We're going to be out, and we're not going to. We're going to go with whatever the management team wants, because we don't want to be too hands on.
Right.
And then we've seen that shift.
Yeah.
Right. And now all of a sudden, it's in certain cases it's taken a little bit more. I think some of the private equity folks are taking on what we've seen in the in the Bay Area around the venture model, which is a lot more services, right, that they're bringing. So, hey, we can help you with talent, we can help you with marketing.
Yeah.
Some of the PE folks that we're talking to have said, yeah, we can help you with how to optimize this. Now you're going to be holding this for a lot longer period of time. What can we do to actually share knowledge across different portfolio companies? And by the way, it's also good for the certain PE shops that might actually have to report on ESG stuff and some other things. It's like, is this information available? Are you able to impact decisions? Those kinds of things.
Yeah. Can you talk about so you mentioned some of the hubris and stuff. And I think people can come in and they think they can solve every problem.
Mm-hmm.
And it seemed like you guys have kind of narrowed to production, but I know you've dabbled in other sides. Just like how has that evolved for Kelvin, and how, where have you guys kind of found the sweet spot?
Yeah. So for us,
some lessons learned too, because that's, I think, as someone that has been in product for the last few years in the energy tech scene, I think that's a very tricky thing, right? Because it's, hey, there is this kind of tech boom in the energy space because there is so much opportunity, like you've talked about, like there's so much, but then there's also, it's like, well, which one do I go with? And then like, there's that balance of focusing and going all in the same direction, but also as we grow, we need to continue to add new things if we want to keep growing kind of mentality. And so
the key is to find the pain.
Yeah.
Right. And for us, the pain initially was production, right? Where folks were saying, don't have enough engineers, don't have enough time, want to be able to increase these things. And so that's where we started. And we were fortunate, right? We had some early wins, and we found sponsorship coming out of, there was a group of folks who, at BP who got like excited about what we were doing, and were in a position where they really wanted to affect change. Okay. And there's a lot of serendipity in that.
Sure.
But it was about being able to really support what their initiatives were with a technology that could actually have real impact. Because I think this is where, when you're selling to engineers, you have to, it's like, identify the pain, but then you have to deliver a solution, right? And if you do that, then you curry favor and you get more and more opportunity. And we were able to do that, with that team. Over time, what we found though was, our business, as I mentioned, had hardware and services and software and other things which are just, they don't scale as well. Yeah. And there are a lot of dependencies.
There's also, generally speaking, they're also very different business models too.
Exactly.
Right? Like field service, hardware, and software are all standalone businesses as they exist.
And the field service, you don't even get into like the insurance and the things you have to have, even if you're on the surface, but technically if things go down whole, it's insane.
I'm not going to get into that rant today.
Yeah. So one of the things I met with a very large controls company that told me, and this was in 2019, they're like, we're getting out of the hardware business. I said, oh, that's odd. Like, you're a huge hardware provider. And they're like, yeah, we're not big enough scale. We're not like Foxconn, Apple. And I said, if they're too small, what am I doing in this space? This is ridiculous.
For sure.
So then it really forced us to rethink what we had in terms of, a real understanding from a software point of view and where we were strongest. And at that point in time, there was also an awareness that we needed to continue to upgrade our team on the control side and also on really building enterprise grade software, given the types of companies that we were going after. And so that meant we brought on some new people, and we changed up the leadership team, and we upgraded a lot of these key positions in areas that we knew were going to be important. Yeah. And then what happened was we were fortunate because we had demonstrated some success already about being able to get software to work in remote, challenging environments. Yeah. Okay. And we had a large, nobody that we had marketed to, a large company come to us and say, we have a problem. We are in a position where we've developed a lot of really interesting software and applications, and we know it works.
Yeah.
We've done it, but we've been cranking on how do we actually get this stuff to operationalize and into the field for 2 years, and it's not working. And we said, we got you. And at that point, we went from being purely in production to starting to move into the completion side of the house, and starting to realize that their problems were not so unique relative to what we'd seen on the production. They were more complicated because you're talking about, moving crews around and lots of dynamics and complexity there. But you could still distill it back down to this point about, you have an engineer you have some expert frac engineer who's decided they have an approach for this particular part of frac that they're best in class at. Great. Let's put that into an application. Yeah. And let's help them be able to then get that into the field and run and be successful. And that has led to both continued opportunities there, as well as on the production side, the acute pain of, I recognize, I know I have a solution for this, but I can't deploy it successfully and scale it. that has been pretty critical for us in finding those opportunities. And then once you do that, then it builds, right? And you end up with folks who are saying, hey, I see you did it in one part of, like, we have, we've talked about Santos, that's, sort of what we've done there is public. Like, we're doing a lot of work with them, but that started really with some pretty simple initial production optimization application. And now today we're moving really across the enterprise.
Yeah.
And that's been because we have been able to demonstrate, we understand what the engineering problem is. We can help them put that into an application, and then we can support that at scale, depending on wherever they want to put it.
Yeah. So I've got an interesting question, because we've got a lot of similar experience as far as the data field side of things. What advice would you give to somebody? Because the oil field, I think one of the things that a lot of people underestimate coming in from outside of the oil field is that the oil field is unique around the fact that the operators own all of the data, but they generate next to none of it. Right. And so, like, if you're Google, it's very easy for you to control the input and the requirements and all of the data that you're then turning around and analyzing and throwing at models. The problem with, especially on the drilling and completion side, is the fact that all of the data that's generated over there is generated by dozens of different service companies in different formats and different standards, et cetera, at different timestamps and intervals and all that fun stuff. And my hypothesis was the reason y'all it's not just y'all, there's been a number of companies that have started in software, got into the hardware space, in my opinion, as a means to an end, because there was no good way to get the data into the software. And then realized how difficult, it's not even necessarily hardware, but it's the field and the hardware component of all of that is, and how obnoxious things like insurance are, and all the safety requirements to have guys out in the field and all that stuff. Can you just unpack that a little bit? Because I think there's a lot of people that have an idea for a piece of software or whatever, but then it's like, well, if I only had this data, or if I only had a way to pull data from this thing or know this specific thing, and you guys have a unique kind of experience. You specifically have a very unique experience around that. So kind of talk about that a little bit.
Yeah. So I think, as you've articulated, your software is only going to be as good as the data that goes into it in terms of its ability to take appropriate action. Okay. So for us, what we realized was initially, we're going to go gather that data sort of raw from that particular pump and use it to define different types of insights and actions. Fast forward, what we also then recognize, though, is there are multiple ways to gather that data today that may not have existed 3 years ago, 4 years ago, et cetera. So what we will find is there probably does, if you're talking about working in a remote environment, you can't rely on the cloud. Okay. So that's like,
I want to get in on that.
So let's talk. We can talk more about that. So there's just way too much interference, wireless problems. You've got lots of things that are happening in the Permian today that will impact any sort of like cloud system having true streaming data that's pristine.
And no operator will ever sign off on any kind of automated or remote control if it's cloud-based, because of the fact that if it goes down 0.01% of the time,
that's enough.
That's enough that the risk is so high in the field that's enough that it's.
That's right. And so that's led to this real need, and kind of where we've spent a lot of our time is this hybrid world between edge and cloud. Okay. And so a typical way that we would approach that is to say, okay, well, what operation are we talking about? If we're talking about completions, then you're probably going to want to have some additional compute that's sitting in the van, right? And that's pretty straightforward, because there's already compute that's out there. Maybe you add another box, but it's going to be a generic Linux box that's hardened, or you partition something that's already there and you use that compute and storage. Great. So now you're getting a much more direct source of information. And you can sort of measure the purity of that to determine how good it is. And you can, do your analysis to make sure that it's good enough to use for something else. But you're doing that at the source. And that's a big thing. Is part of the reason we've designed our product the way we have is we want to be as close to the source, not just to read the information, because we're a controls company. We need to write back, right? So having the ability to get access to hardware that's going to give you the information you need can be yours. You can partner with somebody else, but that's critical.
Sure.
Once you have that, what we find is most of the time you're going to be making changes as close as you need to at, to that system. So that could be, maybe you are making control changes at the edge. If you're doing that near real time or on a streaming basis, that totally makes sense. If you're making a change once a day, maybe you can run that out of the cloud.
Sure.
Okay. If you don't, so that time sensitivity depends on the nature of the control decision that you're making.
Yeah.
Okay. So it gives you flexibility then to figure out, because the closer you get to the edge, the more expensive your compute and storage is, right?
Yeah.
Versus you're in the cloud, compute and storage is cheap. You're at the edge, compute and storage is expensive. And so there's a calculation as to where you want your application to run, right? So if you can build a really sophisticated, interesting model, but distill it down to a rule, E equals MC squared, you can put E equals MC squared in an application and run at the edge.
Yeah.
Real easy, right?
But if you need to run, train, and do all these,
you're going to do that at the cloud. So it's this recognition that you want to be flexible and not try to force all of your models to the edge. You don't need to do that.
Yeah.
You need to decide what are the decisions you're making and put those as close to that asset as you need to.
Yeah, I think that's a big question, I would say, around edge with a lot of people is it's like, well, what do I do here? Like, why do I do it here versus there and all that stuff? And to your point, like, people don't think about like the urgency of a decision essentially. And it's like, if you're trying to make a recommendation or something on an operation that's happening with people on it in real time, that has to be done as close to the data as it possibly can, at least in the oil field.
Yep.
But, like you said, if you're opening and closing a valve once a night or checking if the condition of something, probably not that urgent, right?
Yeah, it comes down to that definition of real time.
Right.
Like some of these real time things are literally microseconds, and some people mean in 10 minutes or,
That's right.
or a day is real time for some people, depending on what they're doing. I was
going to say, especially from like the SCADA side or production and SCADA to operation or drilling and completions, right? Real time is very different. Like 15 minutes is real time in SCADA world, but real time in completions is 1 second, and then real time on hardware is nanoseconds, milliseconds, right?
That's right.
So it's an interesting thing, but I think the two like big things for me going into the edge space and all that from the energy side was that ability to have basically what is it called? I'll remember the name in a minute, but controls in a disconnected environment.
Yes.
And which essentially means that the next step of that is automated controls in a disconnected environment. So that's the future. You're automating some of these things, truly automating them in the field and letting them run.
And that's really what we've been able to do.
But then the next thing is federated learning with some of that stuff where that gets like that. A lot of people struggle with what that is, but like when you look, like ChatGPT is the best use case that the average person understands about federated learning, right? Like millions of people downloaded it really quick. Lots of people are using it, and they have continuously improved that model month over month, week over week, because it's continuously being trained on individual edge case models, essentially, right? And so that's the federated learning stuff is just, I think that's going to be us coming out of the trough of despair for AI ML is like people getting these federated models really down, getting them into production, and just seeing how quickly they're going to be able to accelerate the learnings of them.
Well, there's an interesting sort of extension to that as it relates to the kind of the oil and gas space, which is historically we've thought about the different parts of the production process in pretty siloed, like, sort of entities, right?
Yeah.
I may have SCADA that runs across my whole system, but I'm using one piece of software to optimize a certain lift type. I'm using another, I'm using some other software to kind of manage potentially compressors. I've got other stuff that's managing distribution, and these are not all tied together in a thoughtful way. And one of the things that we have been able to show is if you can look at these different assets as part of a system and not just thinking about them as a series of like local optimizations, but rather like, what's our global optima? There's tremendous gains you can get out of that. And when it works, it's that sort of thing where people can't quite believe it, but we've seen this in so many other spaces, right? So for me, I always look at financial services as kind of a parallel where it's like, you think about programmatic trading.
Yeah, no, they've had.
Right? That wasn't a thing.
And it's high stakes, because that's one thing we always kind of knock. Like, these people come with their AI and they don't understand the risks, but like automated trading, I mean, like you make the wrong thing, you cost someone millions, billions of dollars. I mean, like,
or crash the market and
or
they have to shut it down.
Right? So I look at that, I'm like, okay, well, that's system level control at scale.
Yeah.
Right. And again, faster than anything we're talking about here. But we know that those models exist, and we know that they work because we've seen people make billions of dollars using that. And over time, as you start to bring some of those concepts, those network concepts into these types of systems, you're going to be able to unlock some really interesting things. And so you talk about federated learning. I think about that also as there's some interesting causal inferencing modeling and some stuff there where you're getting into a world where, yes, ChatGPT is awesome, and there's some really cool tools around that. I'm not sure that's going to have the same transformational effect on this sector as you will see some of these other fields of machine learning and emerging, categories of AI, because the beauty of control is, every time you make a decision what the impact is.
Right.
And you can learn every single time
for sure
what that is. And I look at that and I say, oh, we're gonna be able to open up.
Because you're saying that when it's a system like that, if even if my pipe diameter goes from here to here, that like there's this different pressure, temperature, PVT conditions that are affected by it. I mean, you're talking about production that obviously impacts your marketing and midstream side.
Yep.
I mean, it's funny because it's not just production or that side of the space either, right? Like completion. I mean, frac interference is like the perfect example of this that I first noticed, right? It's like, I don't know how, it was probably damn near 10 years ago. I went to a conversation that it was some luncheon Dave Kramer, shout out to Dave Kramer, at Conoco did, but he was talking about they were doing new wells and like new wells in a semi-depleted area of the Barnett, and they were having so much trouble fracking them, and no one could figure out why. And they were just looking at the individual fracks or wells. And so I don't remember how he ended up looking at them, but Dave took a step back, looked at all the wells on the map, and we're like, well, these two wells over here have been producing for the last 2 years, and their reservoir pressures are super low compared to the normal reservoir pressure of the Barnett, whatever that may be. And so he started just thinking about it physically and holistically. And he's like, well, they're just pressure sinks. Like they're just sucking, literally
high to low,
sucking the fluid away from what they're trying to stimulate. And so guess what? They shut in those two wells. I think they ended up loading them up and stuff, building the pressure back up. And then they had no problems fracking the well in between them because it no longer had this normal physical phenomenon known as pressure. And so like the fact that, even just that's a completions engineer on a, not even a pad, but just a small part of the field. Yeah. But like the fact that the oil industry as a whole, no one, because of how it's segmented, no one thinks about how the drilling schedule impacts the frac schedule, impacts the flowback schedule, impacts the production schedule, impacts the marketing, impacts the sales, impacts the refinery. Like it literally impacts the entire thing, and anything along that way has impacts both upstream and downstream of it.
That's right.
And
but you've got contracts you got to meet,
right? And so it's like it's this giant dynamic multivariate system, but most people don't think about it that way. They don't model it that way, and so it's really cool that y'all are able to start pulling all that.
We believe you have to put this in place starting small, right? You start with production, and then you get into midstream, and then you get into other parts of it, and you begin to sort of build this up. I like to think about this as much more of a biological system, right? It's a series of cells that you're just saying, like, we're going to connect these together. And like the production cell is going to talk to this cell over here on the distribution side, and they're going to connect that. And like, that's what again, very high level, but that's how we conceptualize it. You touched on something else that I think kind of tying back to AI that I also wanted to highlight, which is there's also an awareness that AI and sort of data science alone is not going to be what solves all the problems in this world. Like we have to think about this in a much more hybrid model approach, right? You need to be able to think about, how do I take a physics-based model and how do I use it potentially and augment it with something else? Yeah. Like those hybrid approaches are possible today. And that's the other piece that I think we're going to start to see maybe some unlock, which is okay, I've taken this model that I had that was pretty good, and then but I've been able to modify it to some degree to turn it into something that is a little bit more data enhanced, and see what those results are.
Yeah,
true.
And that's kind of where I think, again, a lot of this is hybrid. It's not going to be black and white, binary, super clear. It's going to be more of these blends that you're going to bring up.
Yeah, that people think that AI is going to replace their jobs and stuff, and it's like for the short and near term, AI is just going to enhance. Right? It's going to streamline, trim time, like all of that stuff. Like it, and Friedman, he was on the Rogan podcast talking about, he's like, everyone thought we were going to take blue collar jobs with AI out of the gate, right? And it's like, it's actually just enhancing all of these other jobs that are more creative or whatever, and it's not taking them, it's just making them easier, faster, more streamlined.
It's a tool.
And maybe this is too frank, right? But it's like, if AI replaces your job in the next year or two, you're not very good at your job.
That's one
I mean, like,
learn the AI and become an expert in it, and even prompting, right? Like,
it's funny. I have a friend. This is outside of this space, but I have a friend who he's a lawyer. He's a law professor at University of Colorado, and his name is Harry Surden. He's done a lot of work in AI applications to the law, and all over LinkedIn, lots of activity. And we had breakfast a couple months ago, and he said, I just have my cousin is graduating from college right now. And I'm like, oh, that's interesting. He goes, do you know what I gave him? I'm like, no. He's like, my graduation gift to him was an OpenAI subscription.
That's awesome.
Because he said that if you understand this and you actually learn these tools, you're going to be so much better, regardless of what job you go after next. But just figure out how to get some mastery of this and see where you can go to. And I thought that was insightful, right? Because it's a tool, right? And it's not scary if you actually start to use it. Right. It's actually really empowering.
Well,
but
you can understand the bounds of it too, like what it's not good at, what it is good at. And that's like one of the examples I used in my pitch deck was for breast cancer screening, right? Doctors alone were like 80% accurate. The ML, it was a computer vision model. The computer vision model of I think their MRIs was like 75%, whatever. But combined, it was over 90%.
Yep.
And that's literally millions of lives of people who were saved every year just from that. And so like the hybrid approach is absolutely, I think people haven't been told, or like people don't talk about that a lot in public or just in
like
general.
Zero sum.
Right.
It's like
it's this all or nothing, but that's absolutely not how anything works.
That's not how this works. Right? And so I think that's where there's so much potential, is if we can stay. Listen, I'm an optimist, and I believe that these are really powerful technologies that can be used for good, right? And now it's a question of how do you make that tool appropriate for the job at hand, and then once you've done that, it will open up new opportunities and new cool things to do, and on down the line.
I mean, like I was just thinking about like the brain computer is what we're trying to go after. Like, so you're always going to be trying to get there. I mean, at some point, the brain is still going to be better or have more capacity.
Yep.
Now different models can maybe be better at more narrow scope things. And I think that's what we're talking about here. Like when you combine like just the overall general computing power of our brains, but then focus it with something more narrow focused, AI, then like that is really, really good at that one thing or a couple things. And
we're better at learning like higher level things than we are, like, cause we're not able to process
like
billions
math,
of data,
like doing like ridiculous math, even adding two numbers that are huge. Like we can't do that. Off the top of our heads very quickly, but the calculator can.
But understanding that, thousands plus thousands equals thousands versus, those types of things are
and I think the human brain is incredible at pattern matching.
Yeah.
Particularly across, I mean, where does AI struggle? It struggles like if I go from text out of a PDF to, text out of a different file type, it may struggle, right? Maybe today it's better, but human brain's going to be able to figure out patterns across those.
Well, that's like we were talking about that frac model that Bobby had written, and we were trying to do it numerically, and I told him, I was like, it's annoying because with frac, like I can sit and look at any treatment plot and tell you exactly what's happening during the treatment, but programming that into a computer is so hard.
Right. How am I going to write that function?
Right.
Actually,
and so there's like so many edge cases.
Which I mean, that's the problem with AI or ML in general is you've got to program you've got to get those edge cases. People,
but
it's
then
like you have good data sets, but you don't just want good data.
But then it's only as good as the data you've given it.
That's what I'm saying. I mean, like you want good data that also has bad things that happened in it, so that you can find
and train.
Yep.
But I think that's where you're seeing like really interesting work, and there's going to be better and better training approaches and things going forward. But you're not going to take that human understanding. Like when we talk about Kelvin, we talk about I want human expertise plus artificial intelligence to yield better impact.
Yeah.
Right? If you do that, you're doing some interesting work.
For sure.
And that's applicable across all sorts of areas.
Yeah, any domain,
right? As well as more broad domains.
So what's give us some real world examples that you can. As far as, some of the impacts you guys have had, or just the findings that you guys have had with some of your.
Yeah. So recently what we've been able to do is, I think this is a classic example of like with Santos, there was a particular engineer who was an expert in progressive cavity pumps.
Okay.
And his approach was, I want to be able to take some information that comes out of a reservoir, and I want to be able to also use information that's coming off of the pumps themselves. And with that, in Excel, I can start to actually help make better decisions around how to manage this stuff. And we looked at that and we're like, oh, that's a perfect, potential application. And there's some real data science in some of that to do pattern matching. And there's some real like sort of human understanding of that process. So if we can capture and codify that, we can turn that into something that can be quite powerful. And so that was very appealing to some folks in Australia who have a lot of progressive cavity pumps. And so what we did is we just started with a typical kind of trial and began to run that and began to sort of see what the results were. And very quickly it started to show production gains that were meaningful. It started to show energy reduction because we were running the pumps more efficiently, reduced number of workovers, and all of the goodness.
Yeah.
And what that has led to is sort of two things. One, expansion of that particular application. So that's now running, across over 1,000 wells. So that's been good growth. The other thing though is it's really inspired the folks at Santos to start what other things can we apply this to? This approach, right? Which is, we have a great engineer who has this awesome idea. And so we're working on actually now 6 or 7 different projects where that concept can be applied, and it can be done in the beginning at a small scale, right? And if it works, great. But I think it doesn't always have to work. It doesn't always work. So then the question is, how do you learn from that and try a different approach, or do you go after something entirely different?
Sure.
So that's an example on the production side. As it relates to sort of some of the work in the OFS world, what we are finding is that you can break down sort of the completions process similarly. And there are great engineers who really understand how to optimize certain parts of the frac process. And in that case, what we've been able to show with them is like, this can have a material impact, both in terms of, are we fracking to plan, right? Are we getting the results that we expect, right? Are we doing it as efficiently as we possibly could? And is it being done consistently? Yeah. So these are all things where historically you can get different crews who have different approaches. Who are thinking about, hey, I've got a slightly better way to do it, and I'm going to kind of take my own sort of understanding of this situation and apply it. Okay, cool. But is that really what the boss wants?
Yeah.
Right. I don't know. Maybe
you can see those biases between the morning crew and the night crew. One guy's way more conservative and taking longer to get to breakdown. Another one rips it open and is overcapitalizing on horsepower. I mean, there's so many different ways to think about it.
Well, that's the other part too, right? Is it's like, how are your contracts written? Are they based off of horsepower? Are they based off of, time, number of stages? Like there's so many things in there that get really, really interesting really quickly. So I'm excited for the fact that y'all are not just focused on, the process, but also the other things that tie into that, right?
Yeah.
Like, I mean, that's always been the thing with frac is it's like, we could frac more, or we could frac, at a lower rate, which depending on my pricing model puts me into a cheaper price, but is that still achieving the same frac, characteristics that I want? Vice versa. How do you know how to do that in real time? Like all those fun things. Bobby and I have had lots of conversations. I've got a lot of ideas on the logistics piece of the frac or sand and chemicals that, I mean, when I was a frac engineer over a decade ago, I was a glorified logistics manager and, company man soothsayer. Just make him happy and make sure all the shit's there so that we can frac, and you follow design and listen to the company man, right? But like, there's all these things on the logistics side where it's like, hey, the sand hauler got tied up for whatever reason.
Totally.
And then now you're short on sand, so you can't start pumping, and now you're getting charged MPT. Like, again, all those secondary kind of
knock-on effects.
Effects that come from all of those things. So that's really exciting stuff.
Again, and we feel like there are so many of these examples where you have engineers who have great ideas. But they don't necessarily have the tools to act on them.
Right.
And if we can be a provider of tools to help take those insights and turn them into actions, that's a win, right? It's a win for the engineer, it's a win for the operator, and it really has like huge positive benefits across the industry.
So talk real quick about the kind of productionizing and scalability piece, because I know that's another thing that a lot of people
way underestimate.
They don't think about until they're there, and they're like, shit.
We'll get a Raspberry Pi and
Yes, we have some scar tissue around that topic.
Everyone in the IoT
everybody who's touched IoT has it. I think you have to start with, do you have a good foundation of information, right? And that can be, if you've got redundancy through your data sources, you're going to be probably just fine. So figuring out what that looks like, that's the first piece. The next piece then is, do you have a feedback mechanism on whatever that application is that you're running? Because there needs to be buy-in from the engineers. Because I sort of characterize, like, to some degree, builders and users. Like, there are people who are building applications. So you may say, hey, I've got the best, optimization model ever, and I want to use that. Great. You can create that, you can build that, and then we can help you deploy it. John's got to actually use it. Right? Are you going to use it? And you're only going to use it if you think, A, it has to show up that it has real positive impact, and B, it needs to consistently be able to, you need to interact with it to such a degree that you trust it. Right? Because trust is the thing that people forget, is that if you lose trust with any of your operators or otherwise, they'll figure out every which way they can to turn you off. Right? So we feel like consistent feedback about how is this performing. So we talk about, when you define an application, you articulate what the inputs are, you have whatever logic you've created, and you have outputs. Outputs are speed changes and otherwise. But the other piece is impact metrics. Like, what are you measuring, right?
So what?
And the impact metrics has actually been something that we've really focused on recently, because it takes away this whole conversation of like, who gets credit, right? And you're like, the decision was made, we can measure what the result was, and it's clear the application was working and it delivered that, or somebody turned off the application and it delivered a different result. So now you've got this really nice log that's auditable. You can go back and you can learn from that. Okay. So that becomes part of the caring and feeding that needs to happen with these applications. You can't just drop them in there and they work forever. So that means, from a resource perspective, if you're working on that for your company and you're developing it, you're gonna have to allocate some amount of time to retrain. Right? But you can understand when those impact metrics go outside of a range that you're comfortable with, that can trigger it. Or if John says, hey, it's not getting me what I need, then that can be another trigger. And all of a sudden, you now have a much more collaborative relationship. Because I think one of the other things that we've noticed is, many of our customers still have silos between the software engineers and the production engineers. Right. Let alone a data scientist, let alone you've got all these silos, and we're in a day and age where it's super easy to actually collaborate between people. But you don't actually speak the same language, right? You speak Python, who knows what you speak, but like some combination of Excel and something else. So if you can help bring those people together, share a view on what you're trying to achieve, be able to give feedback around how this application is actually performing, you're going to come up with new ideas. You're going to be able to give him like, hey, every time I see this, there's a problem. Can you sort of write the code to do something about that? So now you're getting like real value across both production and software engineering.
For sure.
And that's how we sort of see you have to. Now, you don't always have to be the developer. You can use a third party if you want to,
Right.
and otherwise. But at the end of the day, you have to have buy-in that this works.
Yeah.
Because if you don't, you'll figure out a way to sabotage it.
Yep.
Oh, that's very true.
Yeah. And I think just talking about the scaling part is like, I've been on projects where like you have some really talented data scientists or machine learning engineers. They don't know ML ops. Like
Exactly.
deploying those is not the same skill set.
Totally.
Like,
Yeah. So data science, data engineering, actual application development, like these are all different areas of expertise.
Yeah.
And what we've been trying to do is to sort of simplify that as much as possible. So
Yeah.
our pipeline can be, you've written something in Python. Again, you can define inputs and outputs and impact
Sure.
metrics. You probably can.
Yeah.
Great. We'll wrap that and push it out to an application. You get to evaluate it. Go. You don't have to.
it's hard to push a Jupyter notebook into production.
I can show you. We have a way now, actually.
Yeah.
But I think those are the types of innovations that are also trying to just simplify what has historically been a complex process.
Yeah.
And the easier you make it, the more leverage you get.
Yeah, no, I think a lot of people think, oh, well, you're in software, so like you can do everything. Like,
Well, it's like people
you can
thinking
stand
I'm
up
in IT
servers,
and
right.
you know, hey, come fix my printer. You know,
Yeah.
like,
Exactly. I still fix my father-in-law's printer.
Yeah.
So
I know Bobby and I do the same with all
Yes.
of our relatives. No, but that's people. I think a lot of it is just we're not the energy industry in general is not nearly as familiar or experienced at building software, especially at enterprise production scale. And so it's one of those things that you don't know what you don't know.
Yeah.
And they're like, oh, we can try this out and do it. And then they get into it and like, oh,
I was
like there's a guy that has to do the data engineering and then a data scientist. And then you've got to have someone that does the architecture and the
Right.
servers and the management and then the production and management of all of that stuff. Like there's so much more to it. Oh yeah. Then you need a GUI that
Yep.
is pseudo useful and intelligently done and, intuitive in some kind of way. And that's another person that you
Yeah.
need. That's
Ask me how we know that, John.
But what's interesting about that too is what we're finding is there are still operators that want to build it all.
Yeah.
Mhm.
And you've got an ambitious, IT department, and they understand how to use Docker, and they've got ideas around, open source this and that. And the challenge is like in those cases, you walk in and you're like, yeah, you could do this.
Mhm.
You could do what we're doing over 2 years, and then you got to maintain it, and then
Yeah.
you've got to and is that the highest and best use of your time?
Yeah.
Right. That's the thing I keep coming back to. I'm like, of course you could. Because if you
Yeah.
tell an engineer they can't do something, they're
They're
going
gonna
to
figure it out, yeah.
figure out how to do it just to spite you.
my
Right.
fastest way to motivation is to tell me I can't do something.
Right. So you're like, you 100% can do it.
Yeah.
That's not the question. The question is, should you do
Yeah.
it? Like, what are you best at? And that's where we come back to comparative advantage. Like, we're really good at understanding how to deliver control software. We know that applications can optimize assets if you use our system.
Yeah.
So you don't have to worry about that. We got you. Go figure out how you build more applications because
Right.
if you do that, you're going to get more optimized assets.
Yeah.
That's great, right? That's a win. So again, it's trying to figure out exactly what we do well and we can complement what others do well. And for others to recognize that, yes, you could do everything, but should you?
Yeah. No, I mean, I think even within the industry as a whole, a lot of people struggle with that, right? Like, should we just be software or should we do software and hardware? Or should we do, should we just do data or should we do data and software? Like,
Right.
These are firsthand experiences Bobby and I have had. And it's one of those things that it's getting a lot better because the industry is finally opening up to, JVs, partnerships, and like actually working for vendors and operators, and more than one player is coming to the table to say,
Yeah.
hey, it makes a lot more sense for me to do the data and you to do the software because I've done data for the last 20 years and you've done software for the last 20 years instead of us trying to compete against each other for this same
Totally.
new solution.
And be poor.
Right. And
versions
both
of
be
that.
poor,
Like
crappier
I
versions.
said, I did a full stack web developer bootcamp. I would not pay me to build a website. Right. Like, I mean,
Right.
but I can speak your language and we can have good, intelligent conversations or relatively intelligent.
Which is good. Like, you need some of that
Yeah.
because you also need IT teams that can call BS
Sure.
on folks who are coming in and selling them like the moon and the stars.
Yeah.
Our approach now is like, there's a lot of really interesting smaller companies that are doing super interesting stuff.
Yeah.
Great. We can collaborate with them. Right. I was with Jose Silva from Zacta
Yeah.
earlier. Right. And, they should be a partner of ours. They are a partner of ours. We worked with them back in the day.
Yeah.
We're now in a position where they can make recommendations. We can take those recommendations and act on them.
Yeah, it's funny. I was thinking about them when you were talking about stuff, because I mean they're a little higher. They're abstracted away, say for the pump side for the most part.
Yeah.
But like you guys, but they really play well.
Totally.
Yeah. So.
But even then, you see like you can build a model in Azure Studio. You can do something in Seek. You can do these other things, and those become, again, the logic that can drive an application.
Yeah.
But we don't have to. We're not going to do everything. We just want to do our stuff exceptionally
Really well.
Yeah, and that's I think that's to all the CEOs and entrepreneurs and folks out there. That's such a like it's so simple, but it's also very hard when you're a company and you, especially in a space where there is so much opportunity, because then they bring you, oh, but whoa, if you can do this with that, then can you do it with this? And you need to listen to that and document that and keep that there. But being able to focus and specialize, I feel like there have been way less companies that have failed because of that than have failed because they got way too outside of their specialty and spent a bunch of time and money on stuff that they're not very good at. And fell apart.
And listen, we're guilty of that. I've chased a whole bunch of shiny things, right?
Oh, I mean, it happens.
It's human nature.
And again, that's where I have to sort of keep coming back to say, okay, what are we really the best at? And how do we continue to sort of invest in that and be focused on it? But it's hard. Right? It's not something that's easy for me to say no to opportunity, but it's what's required if you're going to actually be successful in the long term.
I'm a product guy, so I love spinning new stuff out.
Kind of like Steve Jobs, something like focus isn't like doing one. It's like saying no to 1,000 things.
That's right.
That, like, but do you want to jump into
that hour flew?
Yeah, no, it was quick.
I was not TikToking earlier. I was trying to find my list of questions that I can no longer find. So we'll do a mixture of them because I remember a few of them. But Mac, Linux, or Windows?
Linux.
You want to throw in just the open-ended ones because I probably can't remember all of mine.
I was gonna ask him a real tough one: Houston or San Francisco?
Houston.
Ooh, spicy.
Coming in hot. I like it. GCP, AWS, or Azure?
AWS.
Who's your favorite social media follow?
Any social media.
Yeah, it could be anything.
Could be any topic.
Outside the domain, whatever. LinkedIn, Twitter, whatever.
Peter Attia.
Okay.
Favorite top 3 books, or just 3 good. Let's just go with 3 good books because top is hard. But
Siddhartha, followed by what did I just finish? That's such a hard question for me right now.
Yeah.
I'm reading like 4 different books.
You have any good tech focused ones that?
I like 0 to 1.
Yeah.
And
what about business? You've got an MBA too, right?
I do. I'm their
investment side.
My college finance professor is a guy named Gary Smith, who wrote the investments book that I used, that I still refer to. It's just real basic, but it's awesome. And then now he writes all about the limitations of AI. He's also a statistics guy. And he's hilarious because he just tears stuff down.
Sure.
And I really enjoy that because it's good perspective on what works, what doesn't work, what are the limitations. And I think that comes back to, if you understand statistics, you know that like these things are not all knowing.
They're not sentient.
Right?
Yeah.
So great. Like think about it that way and then understand how to apply it.
Yeah. Xbox, PlayStation, or Nintendo?
None of the above.
PC?
None of the above.
None of the above.
No gaming. I'm right there with you. The only thing is I ever played even before were sports games, and then, but
it's hard to not to enjoy NBA Jam.
Yeah.
I've told my kids this totally dates me, but I was really good at a Atari game called River Raid, which was, and I had like a top 10 score.
Is that the one where you're going down a river and the stuff is just moving up the screen at you?
I had like a top 10 score on River Raid, and I took a Polaroid of it and I sent it in, and I'm like, I'm done.
Just mic drop.
Literally, I said I could spend years and years of the rest of my life doing this kind of stuff.
Yeah.
And that's not the highest and best use of my time.
I like that you got a top 10. I'm like, all right,
that's it.
Place that flag. Then we're good.
Onwards.
Favorite open source library?
Pass.
Okay.
Now you know why we went to multiple choice questions. It's hard putting people on the spot. We'll do the last one. What's a piece of advice you'd give to either young startup or someone in the industry or outside the industry trying to get into the energy tech space?
You have to be so resilient.
Yeah. That's a very good piece of advice.
And more resilient than you think you can be, but you can be.
Yeah.
Right.
It's a roller coaster.
So you just keep going.
Yep.
And if you do, you can accomplish great things. And if you don't, you'll fail.
Mm-hmm.
But just the resilience is the thing that continues to show up for me.
Yeah.
There are so many really brilliant ideas out there that don't get executed on because people just don't have the wherewithal to keep going.
Yeah.
And if you keep going, you might actually get there.
Yeah. Yeah. I mean, I'm self-titled startup masochist, and it's one of those things that damn near every startup I've ever worked for has gotten to a point where it's like, we're about to run out of money, or we're running out of money, or we need to find another whatever it is.
Yep.
And it's amazing at how just it seems like sheer luck, the ones that make it, something happens through pure determination and resiliency and grit that, they went to a happy hour and they randomly met a guy the week that they needed money. It's just all about that constant. If I stop, that's the only way we're failing.
That's
right. And it's so true.
It's that's that luck is when preparation meets opportunity.
Absolutely.
Yeah. You just keep doing it.
And it's so hard.
Yeah.
And I think that's the other piece is people never realize how hard it is until they're into it.
Sure.
But then it becomes so rewarding.
Yeah.
Just because you're like, hey, we're still going.
Yeah.
Mm-hmm.
It's not as rewarding.
Probably shines a lot of perspective though too.
It does.
It's just you start to really realize what's important.
Absolutely.
That you have that right support group around you, and that's really what's important.
Yeah.
And then this is just a byproduct.
Yeah. There's also, I think you just have to get comfortable with randomness.
Yeah.
And that's hard.
Yeah.
Because everybody
Something
wants
you can't control.
I'm the best at something and I'm going to get rewarded because I'll work on everybody else. And there are occasions
right
where that happens, but that's the exception to the rule.
Yeah.
Instead, I find that so much of it is just being comfortable with the fact that there are so many things you cannot control.
Yep.
Mm-hmm.
And this is what I talk to my kids about this all the time. I'm like, focus on inputs, not on outputs.
Yeah.
What can you control? Put your attention there.
Yeah.
Great. The stuff that's going to come out of the back end, how well did you prepare for that test will be an input on how you do. Yeah. But if you get all the questions that you studied, you're going to do great. And if you get none of the questions you studied, you're probably going to fail.
Mm-hmm.
There's randomness in that.
Mm-hmm.
Be comfortable with it. Don't be upset by it.
Right. Don't let the one question that you didn't study throw you completely off.
Just keep going.
Yeah. Yeah. And I don't know how many companies have started in the energy space and just were completely at the wrong time, too early. Started and then you hit a bust. There's so much of that, right? And but yeah, you've got to be resilient because the energy industry is full of very high highs and very low lows.
Yep.
It's part of it.
It requires a strong stomach, but it's also incredibly important work.
Yeah. That's the biggest part, right? Is energy goes into everything.
Yep.
To manufacture anything, you need energy.
Yeah.
Yeah.
And that's why these guys started DW. So not enough people talk about it or realize it, think about it in their daily lives, right?
Yeah, because they take it for granted.
Absolutely.
Until you've got, rolling blackouts in
California,
it's not
there,
and ice storms in Texas.
I was going to say, I was out of power for 3 days.
Yeah, the ice storm in Texas, it was crazy how quick we went almost to felt like what I would imagine third world, people were waiting at the one restaurant that's open,
right.
Yeah.
And then that's where I sort of see, as we think about demand, right? There's 1 billion air conditioners are going to come onto the market in the next 10 years.
Yeah.
Right?
Yeah. And then
and not to mention all the new GPUs to power all the AI and all of that stuff. So that was that was one of the first lessons I learned about energy. Was like, hey, guess what? Energy's not going anywhere. Demand for energy is not going. The source of that energy may change throughout time. But the energy industry is literally never going away. Right? Like energy is required for human flourishing.
Exactly. That's right.
Where can people find you?
Kelvin.ai.
Cool.
Best place to go.
Awesome. Peter, thanks for coming, man.
Yeah, thanks so much.
Great to be with you guys. Appreciate it.
Thanks.